Have you ever wondered how memory works? Have you ever wondered how memory in a computer is the same as memory in your brain? Well, I have. I've thought about this a lot, actually. Now, let's try and understand this in a way that makes sense to you. So, at its simplest form, what memory is differentiation. That's it, we're done. It's differentiation. I'll tell you why. No two things are actually the same. We can recognize a pattern in many things, but just because you understand what an apple is does not mean that an apple is exactly the same as another apple. We first need some way of creating differentiation. How about we use a concept that the computer already uses? 0 and 1. That's just the easiest way that we can distinguish things. It doesn't have to be 0 or 1. It could be high or low. It could be dark or light. It just needs to be something that we can clearly know is different from the other thing. Why do we need something that's different from another thing? Really, the reason we need that is so that we can create a unique pattern, right? So let's say we want the letter A. How do we know what the letter A is? Well, we basically have to create a rule. We have to say, okay, A is 0, 1, 1, 0. Just a random pattern of ones and zeros. 0, 1, 1, 0 equals A now. Okay? So put that in a box. Let's say we write 0, 1, 1, 0 on a piece of paper, and we put it in a little box. And now we set it right by our entrance to our house, to the left. Okay? So now we have put 1A in the entrance of our house to the left. Now, how about we tell someone to read that A? But we don't know how to tell him that it's an A. All we can tell him is read the thing that is at the entrance of my door to the left. Okay? So this is an abstract concept. He's going to go to the house and go to the left, and he's going to see, okay, this is 0, 1, 1, 0. Now he's going to need an interpreter. So he needs some type of way of understanding that that means A. And we've already decided, we've created a rule that means 0, 1, 1, 0 equals A. So now he can say, okay, let me check what that is. Oh, it's A. Now, A doesn't mean anything to a computer. So all the computer knows is that 0, 1, 1, 0 means this concept that humans have declared A. And all it knows is the different ways it can tell you that that's A. So it could maybe write it to the screen using pixels. And in pixels, it has a defined pattern of what A is. So, when you type A on a keyboard, it's telling it, I want to put this pattern of pixels on the screen. So let's say we have an electrical pattern. Now, an electrical pattern is a pattern of resistance in electricity. And all that means is that when we click the key A, it's just a unique pattern of ones and zeros of high electrical currents and low electrical currents over a period of time. It'll tell us that that unique pattern is also equal to 0, 1, 1, 0. And we know that from before 0, 1, 1, 0 is A. Now let's take a step back, actually, because when we clicked A on a keyboard, that was a way that I could get rid of myself out of the equation. So instead of me putting that A in that house, how about when I click A on a keyboard, that A is placed in that house. That tells that person to go check in that house and see what was put there. So how do we know that one unique pattern is equal to another unique pattern? Well, in a computer, we connect patterns to that specific pattern. So let's say I want this pattern of electrical signal when I click this A on a keyboard to be interpreted as 0110. Or another way to say it is that pattern is equal to 0110. So whenever I click that A on the keyboard, the computer knows that that's 0110. Now if I want to display that onto the monitor or the screen, it says that pattern of 0110 is equal to this pattern of pixels on a screen. So the pixels are just locations based off of the previous location. So, you have a pixel here, 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 and then you can make an A. That is the basis of what memory is. However, we can go much deeper into this because memory is really what makes up everything. You see, memory is actually the same inside your brain. The way you remember things is the exact same way. So, when you remember something, your brain, all it's doing is linking one pattern to another pattern. That's when your neurons, when they connect, I've made a new connection. Whoa. When a baby sees an apple, right? It sees this apple and it means nothing to it. It's just a random pattern of light that it senses on its retinas. So as the light comes into its retina, there's electrical signals that are firing, and it's creating this random pattern. Now, once the baby's mom maybe says, apple, 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 the baby hears this random pattern of waves in the air, which is just vibrating these little hairs inside your eardrum, and it's saying, wait, apple, this pattern of electrical signals equals this pattern of visible light signals? That's how the first connection can be made. You find out that an apple equals the sound wave apple. And now, whenever someone says apple, you can visualize in your head, reproduce, you have access to the node where you saw that apple. It's imprinted in your brain. And now, when you see an apple, you have access to the memory of apple. You've stored that in a location in your brain that you can now actually go to and remember what an apple is. So, what about taste? That's another biochemical pattern of electrical impulses. So, as you bite, that creates stimulus in your head, and now you can connect a new pattern. You have 5 senses. So you can connect taste, smell, touch, sight, and you can connect hearing, sound. So all these things, it's how we make sense of our world. And all we do is we connect things. We're connecting machines. And just as a computer connects a keyboard, an input, to an output, a screen, those are 2 ways that it can interpret the physical world. But it's not making any conclusions about those things. It's just showing us. It's taking our input and it's showing us output that we want to see. Now, the future may include, artificial intelligence that's able to somewhat interpret information, but at the moment we are in a pretty basic stage. So, computers, all they can do is connect things. Although, if you really think about it, humans, all we can do is connect things. So, it's the basis for memory. There's a more complex topic called information theory that goes much more in depth to how information is really made up. And really all memory is information. Information is basically, you have random data and you can interpret it over time. So what is memory to wrap up? Well, we've understood that memory is just linking a unique pattern with another unique pattern. So in a computer, you could have a unique pattern on a keyboard, and you can connect that to a unique pattern that represents something like A, the letter A, 0110, imagine. And then you can connect that to a pattern on a screen, a pattern of ones and zeros that represents locations to write pixels on the screen. Now, the way a human brain can do this is it can link vision, a pattern where you see an apple, to a pattern of vibrations in the air, and it's the same kind of idea. So we've really understood what memory really is just connecting information together. Now, why don't you use your memory to think of what does a like button look like? And why don't you click that if you got something out of this video? I'd really appreciate it. Thanks.